Number 4, you're asked to multiply, and these are monomials, so there's no plus or minus signs. I can rearrange it how I want. So I would do 1/3 times 12, and then I would put a to the 5th times a to the 1st. So 1/3 of 12, 3 cancels into 12 4 times, so I would have 4, and then a to the 5 plus 1 before a to the 6th. Number 26, no plus or minus sign, so I can rearrange it and do 3 times 8, do x squared times x to the 5th. 3 times 8 is 24. Add the exponents on the x's. 2 plus 5 is 7, so 24x to the 7th. 35 is the distributive property, so I have to do 9s times s, and I have to do a positive 9s times a positive 6. So 9s times s is 9s squared, and then I can multiply 9 and 6 and get 54s. For 53, I think I'd want to do the box since it's a binomial times a trinomial. So I like to put the trinomial on the top and the binomial down the side. So x times x squared is x cubed. 1x times negative 3x is negative 3x squared. 1x times 5 is 5x. 2 times x squared is 2x squared. 2 times negative 3x is negative 6x. 2 times 5 is 10. So then to put it in pretty form, my highest exponent is x cubed. Then I can add the squared terms together. So 2x squared plus a negative 3x squared. Different signs subtract. Keep the sign on the 3. So that'd be a negative 1x squared. Then negative 6x and 5x. Different signs subtract. I'm going to get 1. Keep the sign on the 6. So that's negative 1x. And the 10 is positive. For number 16, you're adding the like terms. So 4k cubed and 9k cubed are like terms. So I can add 4 and 9 and get 13k to the 3rd power. And then I can just add 6k squared because I can't add 13 and 6 because the k's are not alike. On 28, since there's a plus sign in between the parentheses don't mean anything. So I can combine 3z cubed, 2z cubed, and negative 2z cubed. Well, these are going to drop out and make a 0. And that just leaves me with a positive 3z cubed. Then I would want to do the squared term. So I only have one squared term, which is a negative 5z squared. And then I can combine a positive 1z and a positive 1z and get a positive 2z. Number 19, you're dividing. When you divide like bases, you keep the base and you subtract the exponents. So 8x to the 8 minus 3 is x to the 5th. 3 minus 3 is 0, but anything to the 0 power is a 1. So if I multiply x to the 5th times 1, I just end up with x to the 5th. For 24, you want to write that in scientific notation. So you divide it up. You say I can do 2.1 divided by 8.4, because this was a division problem. Then it's always times a power 10. So then I can divide out the 10s. 2.1 into 8.4 is 1/4, which is 0.25. And then I keep the 10 and I subtract the exponents, 2 minus 5. So I end up with 0.25 times 10 to the negative 3rd. The problem is that's not in scientific notation. So to get it in scientific notation, to get 0.25 to be a number between 1 and 10, I can multiply it by 10, which means I have to divide the other side by 10 to keep it balanced. So I end up with 2.5, because that moves the decimal over once, times 10, and then I do negative 3 minus 1, because there's a 1 on that 10. So my final answer is 2.5 times 10 to the negative 4th. For 28, if you have a power of a power, you multiply the exponents together. So I would do negative 1 times negative 4. So this gives me x to the 8th times x to the positive 4th. And then when you multiply like bases, you add the exponents. So 8 to the x plus 4 is going to be 8 to the 12th. Here I can just rearrange and do a to the 4th times a cubed, and b to the 1st times b to the negative 6th. So that's a to the 4 plus 3. And b to the 1 plus negative 6. So I end up with a to the 7th and b to the negative 5th. But that's not in simplest form because I can't have a negative exponent, so any negative exponent gets moved to the bottom, or flipped. So it was in the top, now it's going to go to the bottom. So I end up with a to the 7th over b to the 5th. Number 38, you have to state whether each number is written in scientific notation. If not, you have to write it in scientific notation. Well, scientific notation is a number between 1 and 10 times the power of 10. That's definitely not scientific notation. So I can put a decimal in between the 1 and the 2 and make it 1.2. Then I multiply by 10, and the decimal got moved from the end 1, 2, 3, 4, 5, 6 places. And since 1,200,000 is bigger than 1, your exponent had to be positive. For number 49, if you have f to the 0 power, that's really just 1. And then you flip negative exponents upside down, so I'd put g to the 10th on the top. So 2 times 1 is going to be 2 g to the 10th over 7. For number 29, which method would you use to solve each system? Explain. Well, I wouldn't use graphing because it's not in y equals mx plus b form. I wouldn't use substitution because there's no 1 that's a coefficient in front of x or y. So that means what's left is elimination. So I would definitely use elimination. And I would use it because I could multiply the top row by -2 and then add the second row, and then add the equations together. To eliminate the x's.